My name is Jennifer Adamson. This is a parasocial conversation between my book, The Next Internet, A Climate Solution, and a book by Bill Gates called How to Avoid a Climate Disaster. How to Avoid a Climate Disaster opens with, there are two numbers you need to know about climate change. The first is 51 billion. The other is 0. My book only contains two numbers, 0 and 1. It is an example of constrained writing. When covering topics like internet and computer science, I thought it would be neat to only use binary digits. Thus, when it comes to numbers, my book is nerdier than a book by Bill Gates. The two numbers in my book are binary digits. What are Bill Gates' numbers about? 51 billion refers to the tons of global greenhouse gases emitted every year. 0 refers to the emissions target recommended by scientists. This opening guides the conversation toward a countdown of emissions, which is fitting for a book on climate change. Both books share the objective of net zero. Why all the fuss about lowering emissions? We learn Bill Gates came to focus on climate change through the problem of energy poverty. Well, energy poverty is a great segue to introduce internet transport, the topic of my book. For those dreaming of energy poverty solutions, imagine a network of utility tunnels that delivers electricity and internet and modern goods transport. Inside tunnels, there are wires for electricity and digital internet, as well as a conveyance system for packages. Each of these utilities on its own has the potential to improve quality of life and reduce poverty. Combining these utilities into one project could be more efficient compared to constructing several large infrastructure projects. There's more. If this advanced transport system can remove human waste, then it could potentially replace traditional sewer systems, which are essentially underground goods transport for just one type of good: poop. Instead of flushing a lot of water to get rid of waste, just get rid of the waste. If a city is considering building or replacing a sewer system, why not install a modern version that not only moves poop, but also handles all the other stuff? One project to provide the benefits of multiple utilities. It delivers electricity to improve energy poverty. It serves as a sewer to improve sanitation. Hey, it can take away all waste, so this is also a garbage removal system and a recycling program. A system that moves things can deliver. For example, it can deliver bottled drinking water, thus fulfilling a valuable function of yet another utility, water networks. Transport of goods could provide all kinds of supplies to those who need them and create opportunities for business development and economic growth that could reduce poverty. Okay, so utilities improve living standards, but what do these utility tunnels have to do with climate change? If this project were designed to lower greenhouse gas emissions, then the electrical component would likely be some kind of smart grid that uses renewable energy sources like solar or wind. Perhaps the electrical system would be an energy internet. A goods transport system running on clean energy would reduce emissions from freight transportation, which is a large category of emissions on its own. But that is just the start. To understand the full potential of automated goods delivery to reduce emissions, start thinking of it as another type of internet. We have internet for information and communication. That internet moves data packets. This other kind of internet would move actual packages. It is an internet for transportation and logistics. This logistics technology could be called many things. A group of academics use the term physical internet. Consumers might think of this concept as advanced online delivery or the future of e-commerce. I use terms like internet transport or internet for goods management in my book because I think these terms are descriptive. The nomenclature people settle upon is of little matter compared to the potential outcomes of adopting such technology, which I think could be as revolutionary as the first internet. The reason why I'm encouraging thinking about automated goods delivery as an internet is to convey how disruptive and transformative this technology could be on daily life. Cutting emissions will involve disrupting a lot of polluting behavior. Ergo, if you want climate solutions, look for ideas with disruptive potential, like internet. Now, explaining that internet transport could dramatically lower emissions involves overcoming a lot of skepticism. It's not just convincing people this technology is feasible, but also that it could be a climate solution. And many people still don't feel climate change is a problem worth solving. On page 7, Bill Gates admits once being skeptical about climate concerns. He goes on to tell readers that colleagues, scientists, and activists convinced him to pursue research into greenhouse gas emissions, and this led to changing beliefs and taking action. It is wonderful to know that people exist in this world who can change their minds based on evidence, even for claims that initially seem unbelievable. For the best chance of finding climate solutions, we should at least consider unconventional ideas. A feature of the climate change problem is that the systems causing the seemingly intractable pollution have, in many respects, been hugely successful. To those accustomed to emissions, change to avoid climate change will seem radical. Creating another type of internet is a bit like wanting to put a computer on every desk and in every home, or thinking the internet will expand and evolve to become part of everyday life. Within living memory, those ideas were considered kind of crazy. Combining digital internet, energy internet, and physical internet into a super internet could be as revolutionary as the personal computer, the World Wide Web, or the smartphone. Now, I'm not the only person thinking about other kinds of internets. The Economist magazine wrote about the energy internet in 2004 and used the term physical internet in 2006. Benoît Montreuil, Eric Ballot, and others took the concept of physical internet and have been researching and publishing about applying internet concepts to logistics networks. However, I don't think these concepts have entered popular culture yet. My book, The Next Internet: A Climate Solution, aims to share my version of these concepts with the general public. Internet as a climate solution needs to find the types of people who could be convinced to at least consider ideas that don't jive with conventional wisdom. Perhaps the kinds of people who read books by Bill Gates might be open to audacious technological solutions. On page 8 of How to Avoid a Climate Disaster, Bill Gates shares a wish list for climate solutions. 1. To avoid a climate disaster, we have to get to zero. 2. We need to deploy the tools we already have, like solar and wind, faster and smarter. 3. We need to create and roll out breakthrough technologies that can take us the rest of the way. A super internet could help deploy tools we already have, like solar and wind, as part of its infrastructure. As an advanced logistics network, it could distribute equipment to support other climate solutions. I think it is itself a breakthrough technology that could help emissions get to zero. Mr. Gates says, "I'm a technophile. Show me a problem and I'll look for technology to fix it." Well, if you are looking for technological solutions to climate change, the super internet is all the technology. We're talking data analysis. We're talking software, internet, apps, programs. We're talking robotics. I've read critics of How to Avoid a Climate Disaster complain the book is too reliant on technological solutions. My reading is that Mr. Gates recognizes technology alone is not enough. My book does not intend to imply that all that is required is to build another type of internet and emissions disappear. This technology is a tool. Outcomes depend on use. A version of internet transport could operate on fossil fuels and encourage waste and consume a lot of resources and thereby dramatically increase greenhouse gas emissions. Success in eliminating emissions with internet technology depends on how it is designed and how people use it. I also consider the more philosophical nature of the climate problem, that people need to change their thinking. The climate problem is not just an environmental problem of eliminating emissions, nor is it just a technological problem of designing technology to eliminate emissions. Climate change is an imagination problem. People struggle to imagine the extent of what is at risk, and they struggle to imagine the change required to avoid the problem. On page 15 of How to Avoid a Climate Disaster, Bill Gates opines, "There's nothing wrong with using more energy as long as it's carbon-free. The key to addressing climate change is to make clean energy just as cheap and reliable as what we get from fossil fuels." This quote reflects a conventional mindset on climate change, a belief that things are overall fine, but there's just a problem with the fossil fuels. The focus on shifting energy sources from fossil fuels to clean energy, but otherwise maintaining the status quo, to me suggests not fully understanding what is required to get to net zero. I think climate change is just one symptom of a greater problem. A source of climate change is this attitude that humans can do whatever we want, and that is literally not how the world works, at least not in the long term. A few pages ago, Bill Gates recommended the video series Earth's Changing Climate by Professor Richard Wolfson, who states, "No energy source is completely benign." No energy source is completely benign. I think that sentiment needs to be more at the forefront of the climate discussion. We shouldn't be using as much energy as we can. We must stop being wasteful. One of the criticisms I have of How to Avoid a Climate Disaster is that it doesn't go far enough. The book seems generally to try to keep doing what we're doing, just without emissions. To get polluting behavior, but somehow without the pollution. I believe that thinking will be insufficient to solve the climate crisis. Bill Gates' perspective seems to me to match conventional thinking on climate change. Yes, he is at the progressive end of conventional thinking, but I don't consider this a radical book, not at the time of publication. That is why I selected this book for a commentary, because it represents the establishment. It provides a good contrast to my more radical approach. Chapter 1 of How to Avoid a Climate Disaster is sensible, persuasive writing. Mr. Gates provides a synthesis of his research on the science behind climate change. The chapter includes statistics, facts, and expert conclusions. One of the reasons to read this book is to learn how a successful business person approaches a problem like climate change. My book is different in style and approach. I don't try to explain the problem of climate change. Experts have already done that. My objective isn't even to persuade readers that my solution is the best. My book aims for problem solving. We're given this challenge. What can we do about it? I want to talk about problem solving in relation to the difficulties of finding climate solutions that Bill Gates raises in Chapter 2. Chapter 2 opens by describing the increasing dependence on fossil fuels. This discussion is consistent with the view that energy sources is key to solving climate change. Now, a problem-solving strategy is to look for other perspectives. My book considers climate change through the lens of goods management. On page 43, Bill Gates is talking about energy sources and explains, for most of human history, our main sources of energy were our own muscles, animals that could do things like pull plows, and plants we burned. I want to use this quote to talk about goods management as a problem and as a solution. Before greenhouse gases were a problem, humans made and moved their own things. Even exploiting animals to help make and move things kept the volume of goods within the ability of human beings to manage. But once we started using fossil-fueled power machines to make and move things, things got out of control. The volume and complexity of the things to manage became unmanageable for humans. There's just too much stuff. Our mismanagement created problems, including climate change. To cut emissions, we need to create balance. If we have machine-made and machine-moved goods, we need machines to manage those goods. If the problem is goods mismanagement, then a solution could be good goods management. I think the best machines to manage goods are computers or a network of computers, like an internet for goods management. Mr. Gates mentioned using human muscles, animals, and plants as sources of energy not so long ago to highlight the slow growth of adopting various energy sources. For example, over 60 years, coal went from 5% of the world's energy supply to nearly 50%. The conclusion being, energy transitions take a long time. The implication being that an energy transition to clean energy could also take a long time. From the problem-solving perspective, instead of thinking about slow transitions, brainstorm quick transitions. In my mind, computers and internet took off rapidly. The first smartphones appeared in the early 2000s. Within 10, 15, 20 years, these were commonplace, certainly in areas with high greenhouse gas emissions. Remember, a climate solution doesn't need to reach everyone in the whole world, just the polluters. The Venn diagram of people who crave and have the resources to acquire technology like smartphones and internet and hopefully the next internet, and the people who emit greenhouse gases is close to a circle. And based on past experience, we should be able to roll out technology like internet reasonably quickly. With automated goods delivery technology, we're not starting at year zero. Computers have managed goods for a long time. Many items have barcodes, so computers can manage those goods. And that has been the case for ages. Online ordering has been growing over decades. Automation with robotics is also increasing. We already have an internet, so we have a model for the next internet. So if we are looking for technology polluters could adopt quickly, another internet could be a winner, and it already has a strong head start. We know in the past computer technology took off rapidly, but why? Well, we can gain some insight from Bill Gates' discussion explaining coal plants are not like computer chips. Engineers can incrementally improve computer chips, and that is much harder with coal plants that have large capital costs. Well, instead of lamenting the problems with coal plants, brainstorm things that are like computer chips. I think the internet is like computer chips. We didn't install the internet in one go. When we upgrade the internet, we don't upgrade all components worldwide all at once. The internet started by connecting a few servers, and the internet kept evolving, adding more servers, connecting more computers, upgrading servers, upgrading computers, upgrading software, then designing new forms of connections, and so forth. Incremental change is how the internet got better. An internet for transport could use similar principles. Install conduits with a basic system of conveyance. Maybe conveyor belts, maybe delivery robots. Then extend the conduits. Next, upgrade the mode of transport to faster conveyor belts, or monorails, or maglev trains. You don't need to reinstall conduits for every improvement. The infrastructure is the greatest transport system the world has ever known, so use the system to bring better components to the part of the conduit being upgraded. Let robots install the new parts, and send the old parts for reuse or recycling. The system automatically reroutes packages around the segment being upgraded. Imagine how efficient the system could be with continual improvements over decades. Technology has already reduced delivery times for packages from months to days, and even same-day delivery. Imagine the efficiency that an internet could achieve with proper infrastructure and good design. Admittedly, building infrastructure is a bit like coal plants in that it is a big project with high capital costs. It will involve government regulations and little tolerance for risk. A worldwide project could reduce the burden of research and development on individual regions. Standardization and mass manufacturing would reduce costs. This brings us to another concern Bill Gates raises on page 50. Global cooperation is notoriously difficult. It's hard to get every country in the world to agree on anything, especially when you're asking them to incur some new cost, like the expense of curbing carbon emissions. Again, instead of focusing on difficulties, what are good examples of global cooperation? Internet is an example of worldwide technology. Most countries around the world agree to use the same internet protocols, or at least a close variation on those standards. Countries agree on shipping standards. Shipping containers generally have the same specifications around the world, because this improves trade. Well, internet transport would be a modern version of global shipping. In terms of cost, internet transport would motivate countries to adopt. If you want to participate in the modern economy, if you want trade, you need modern transportation technology. Consider a comparison with communication. If everyone worldwide uses the telegraph and operator-connected phone lines, then people can argue legacy systems are traditional and elegant and popular and better than smoke signals and the Pony Express. But when some countries introduce high-speed internet to their citizens, those legacy systems become obsolete. Everyone must upgrade to remain competitive. So do that for transportation. Instead of countries wondering how to afford curbing carbon emissions, explain you can't afford to be left behind in trade. With internet as a climate solution, not only are you curbing emissions, you get the benefit of another internet. It's an investment. A global threat to the environment can bring countries together to find solutions, as was the case for dealing with the hole in the ozone. That's another good example of global cooperation. So I've introduced my concept of internet transport and hinted at why internet transport has features suitable for a climate solution. But how would Bill Gates evaluate an idea like that? His book provides a guide in the form of a chapter titled 5 Questions to Ask in Every Climate Conversation. The first question is, how much of the 51 billion tons are we talking about? I think internet transport could lead to cutting most of the 51 billion tons. Now, on first glance, the data does not support this statement, certainly not with the numbers Bill Gates is using in How to Avoid a Climate Disaster. Many publications show the energy sector is 70 to 75% of global emissions, and road freight transportation is just a fraction of those emissions, maybe 5%. This data underrepresents transportation emissions. Emissions categorized as transportation often only include operational emissions, mostly what comes out of the tailpipe when driving. To understand the impact of an upgrade to modern transportation, also consider the emissions related to extracting and refining fuel, as well as emissions to manufacture automobiles and automobile parts, like tires and batteries. Also, it's not only freight vehicles that move goods. Passenger vehicles pick up groceries and other supplies. If automobiles only moved people, they could be smaller and therefore easier to electrify. Many households might get by with fewer automobiles, or maybe no automobiles, especially if public transportation and active transportation improve. If people shift away from automobiles, governments would have an incentive to improve rail networks, and efficient train routes could reduce airplane use. Even so, this isn't all the transportation emissions. We need to look at automobile transportation as a system. That brings us to Bill Gates' next question. What's your plan for cement? My plan for cement is to use a lot less cement. If you don't have as many vehicles making as many trips, you don't need to build as many roads, and you don't need as much cement. Roads for automobiles generally require cement. Tunnels can be constructed with a variety of materials. Roads need to be repaved frequently, especially if they take a beating from large freight trucks. Tunnels, historically, I'm thinking water mains, metro lines, they last longer. Okay, so less cement for road infrastructure, but most cement use is for buildings. Buildings also include a transportation element in the form of parking. In high-rises, many floors are devoted to parking. Many houses have garages and driveways. In addition, a lot of buildings are warehouses and stores to hold goods. With efficient goods management, storage could be more compact, thus reducing the need for cement in these buildings. So my plan for cement is mainly use less cement. When Bill Gates asks, what's your plan for cement? He's getting at climate solutions need a plan for all categories of emissions. He presents data as follows: making things, 31%, plugging in, 27%, growing things, 19%, getting around, 16%, keeping warm and cool, 7%. When he calls getting around, I think of as moving things. What is wonderful about this book is that he cares about numbers and data. In a footnote, he clarifies there are many ways to group emissions, and the 16% of global emissions for getting around doesn't include oil refining and automobile manufacturing. The 16% also doesn't include automobile infrastructure such as roads and parking. And of course, reducing roads and buildings would also use less iron and steel, as well as construction-related emissions. There would also be reduced emissions from road lighting. So this data underestimates global emissions from transportation. The other way in which global statistics belie the impact of transportation emissions is that emissions in polluting countries like the United States and Canada have higher transportation emissions. As more people around the world live like North Americans, emissions from transportation could increase. Thus, an update to modern transportation could avoid potential increases in transportation emissions. Okay, but what about the other categories? If we have better goods transport, we wouldn't need as much refrigeration. Households would not need refrigerators in their homes if they could get items instantly on demand. That would reduce emissions to manufacture refrigerators, emissions associated with refrigerants, as well as emissions to power refrigerators, which is a big part of household energy consumption. A goods transport system could help households and businesses make better use of space. With less building space, there could be less space heating and cooling, as well as less lighting. So goods transport technology could make good progress to zero out the keeping warm and cool category, what I think of as storing things. With better goods transport, we can reduce food waste. Food will spend less time in storage before it reaches consumers, so more of it will reach consumers. If consumers get ingredients on demand, food is less likely to spoil at the back of refrigerators. Automated goods transport could keep foods humans won't eat out of landfills. Not just composting. It could go to farms to feed farm animals, thus reducing the amount of food grown to feed animals. The system could reduce emissions related to growing things. If we have better goods transport, that could reduce disposable packaging. A lot of packaging is for humans because they're clumsy. Robots might not need as much. If we have an efficient, cheap system to move items around, packaging could be reused. It goes back to the manufacturer. Currently, a lot of waste that you might find in garbage bins or landfills is packaging. Extracting these resources, manufacturing these items, disposing of packaging creates a lot of emissions. If we have automated goods transport, we can reuse more things. Disposable diapers, pens, razors, batteries. Reusable versions with internet transport are just as convenient to the customer. The customer throws things away, but instead of going to landfills, cloth diapers go for cleaning, pens go for refilling, razors go for sharpening, batteries go for recharging, etc. No more disposable plates and cutlery. Use reusable versions. They go get washed. A system to manage goods makes it easier to share and sell items. Consumers don't need to consume as many new products. Instead of selling a lot of cheap things, businesses focus on finding the right product for their customers. That could dramatically lower emissions for making things. And with better goods transport, we can improve recycling. Robots can sort items with much better accuracy than humans. And an internet managing goods could create a lot of useful data. Data could improve decision making. Instead of buying an inefficient small appliance, consumers could rent an energy efficient version and save money and emissions. Instead of a high carbon meal, a computer program recommends a low carbon meal. Policymakers could use data to craft better policy to further reduce emissions. Just providing the data could help innovators focus on finding solutions with the most impact. As for plugging in, installing a network of tunnels is a good opportunity to upgrade the electrical grid, which brings us to Bill Gates' third question. How much power are we talking about? Well, again, the idea is use less than what we use now. For transportation, instead of moving a vehicle, a driver, and cargo, just move the cargo. Containers in tunnels could use an electrical line instead of batteries, which avoids emissions associated with manufacturing batteries. It also means vehicles don't carry batteries, which reduces the weight and therefore energy consumption. Eliminating emissions would require an upgrade to the electrical grid. Whatever engineers come up with for energy solutions, this project can help deliver those solutions. If engineers figure out everyone needs solar windows, this system could keep shipping and handling costs down. The next question is, how much space do you need? Well, the great thing about underground delivery is that it frees up surface space for other activities. This brings us to the last of Bill Gates' 5 questions. How much is this going to cost? I think it will cost similar to a water network or sewer system. Expensive, yes, but within the range of affordability for many countries, especially many polluting countries. Over the next few decades, most places will build or replace infrastructure. The current road network is not built to last, and it is not designed to withstand the challenge of a changing climate. The choice is not, should we spend money on infrastructure or not? The choice is between investing in older style infrastructure or modern infrastructure. Remember, investing in internet transport technology isn't just a cost to avoid climate change. Citizens gain access to a new utility that could improve productivity and well-being. But an investment in internet transport could lower emissions, and that is worth a lot too. At the end of the chapter, Bill Gates discusses green premiums as a tool to lower emissions. Internet transport combined with digital internet creates an ideal medium to deploy green premiums. The system could be designed to collect carbon data to share with consumers. That could lower emissions on its own. Furthermore, policymakers could adjust pricing based on that data through taxes or other means to further reduce emissions. So as I see it, the next internet could do well if evaluated according to Bill Gates' questions. The potential to lower emissions through improved goods management and help deploy other climate solutions, like a clean energy grid, equipment for carbon capture, or implementing green premiums, could fulfill Bill Gates' climate solution wish list. I hope this introduction to Internet as a climate solution has piqued your interest, and you will go and learn more about this topic. For example, by searching for information about the physical internet, or by subscribing to my YouTube channel, The Next Net Project, for more updates.